Welcome again. We start our next lecture on algorithms design and analysis course, sorting algorithm, counting sort. Counting sort is a sorting technique based on keys between a specific range. This sorting technique is based on the frequency count of each element to be sorted and works using the following steps. Assume that we have the input array unsorted A of n elements in the range of 0 to k. N and k should be positive integers. So here directly I should mention that one disadvantage of the counting sort, no negative elements are allowed. The first step, the count frequency of each element in A is computed and stored in another array, say count of size k plus 1. So the array A contains the element, for example, 1, 5, 18. We should create a new array of size 19, k plus 1, the largest element in the array A plus 1. So if x an element of array A, then let x be an element in A such that its frequency is stored at count sub x. Here we have two implementations for the count sort. I will show the second later. Now let's go with the first implementation. Now we update the count array so that each element we have two implementations for the count sorting. I'll show the second implementation later. But here on step 2, we update the count array so that element at each index, say I, is equal to count of I equals sum of count of x's where x ranges from 0 to I. This means that count of I contains the sum of the previous counts. The updated count array gives the index of each element of array A in the stored sequence. Suppose that the stored sequence stored in another array, say B of size n. Now we scan the input array and we place the element in the proper position. Add each element from input array A to B as follows. We set I to 0, C equals A sub I. We insert the element from the array A into B sub X, and we decrement the count by 1 and increment by I by 1, meaning we go to and increment I by 1, so we go to next element of A and insert it on the specified position, decrement the counter, etc. We repeat these steps until the whole array A is scanned. Here is an example. Suppose we have the input array, as you see. The maximum element is 9. So we create a count array of size 10. Indices from 0 to 9. Now we count the number now we scan the input array and compute the count for each element. For example, 0 is not in the input array, so in the count here we have 0. 1 is repeated as you see 2 times here and here, so its count is 2. 2 is repeated 3 times here, 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 so we have, and its count 3. 3 is repeated 2 times here and here. 4 is repeated 2 times. 5 is repeated one time. 6 0 times, etc. According to the first implementation, we have to modify the count array such that each element at each index stores the sum of the previous counts. This is the modified count array. Here 0, 2, 2 plus 0, 2. 3 plus 2, 5. 2 plus 3 plus 2, 7. Or 2 plus 5. 7 plus 2, 9. 9 plus 1, 10. 10 plus 0, 10. Etc. Now we have the modified count array. This modified count array indicates or shows us the positions of each element in the sorted array. Output each object from the input sequence followed by decreasing its count by 1. Now we scan the input array. 1, here is the, sorry. Here is the input array. And here is the count array. The position of 1 is 2. So we insert 1 here and decrement this counter. The position of 7 is 12. So we insert 7 here and decrement its counter. Here its counter. The position of 2 is 5. So we insert 2 here and we decrement this counter, 9. The position of 2 now 8. We insert 8 here, 2 here, and we decrement its counter, it becomes 7, etc. After scanning the complete array, we'll have the sorted array here. As you see, one disadvantage of the count sort is the space complexity. We need to declare the count array and the sorted array. Now regarding the count array, if we have, for example, 20 elements and one of them 10,000, then we need 10,001 elements in the count array. And the second disadvantage is no negative elements are allowed to be in the input array. But it has one advantage, and we will see it. The complexity is less than in the other sorting techniques. There is really another implementation for the counting algorithm. We just need, I will not modify here the count array. We just need the count array, and we do not need the input array. Here, 0, no need to insert in the sorted array 0. 1 is repeated 2 times. We organize a loop or a counter where 1 is repeated 2 times. So we insert 2 ones here. 2 is repeated 3 times. So we insert 3 2's here. 3 is repeated 2 times. So we need the loop to organize. 3 is repeated 2 times. Here is 2 3. 4 is repeated 2 times. 2 4s. And this will be the sorted array, the same as in the previous example. But do you see here in this implementation, we need additional loop for the count. So the complexity will be in square, while in the first implementation, the complexity is in plus k. This is the Python program for the second implementation. It's very easy to trace. We call the count sort function, passing to it the array and the maximum element in the array, which is 8. We declare here a count array of size k plus 1. And you can easily trace the loops. Time complexity according to the first implementation, big O is n plus k, which is better than in the other sorting methods, whereas n is the number of elements in the input array and k is the range of input. We need an auxiliary space n plus k. I mentioned 2 disadvantages of the counting sort. All elements should be positive. If the array size n is small and the largest number k is high, then we need extra space. For example, if we have, as I mentioned, array of 20 elements and we have one element 10,000, then the size of the count array should be 10,000 plus 1. Thank you.